Sudoku degenerates, welcome. Thank you for the follow, Sudoku. And yeah, we are starting off with a nice, easy little warm-up puzzle that apparently inspired Bridge 4, which I solved on Thursday. Now I should turn off dashed grid. This ain't irregular. Why, thank you. Alright. So, normal Sudoku rules apply. Oh, hey, Marty. I believe, yeah, yours is next in the queue. So, every row, column, and 3x3 box, I gotta put the digits 1 to 9 once each. Killer cages. Digits in a cage do not repeat, so this can't be the same as this. And they sum to the clue in the top left. So these 4 sum to 16, these 2 sum to 12, these 2 sum to 10, and so forth. But these have a special rule. So if cages are adjacent to each other, so if they share an edge, like these and these, they have to contain at least one common digit. So there must be one of the 2 digits in this cage must also go in this cage. Oh, hey, Stu, welcome. Alright, so where can we start? Well, for starters, like, what digit in this cage can show up in here? It has to be, these 2 are the same. I can do the same thing over here. These are the same. Oh, and because this is a 2-cell 15 cage, that's either 6, 9, nice, or 7, 8. But green can't be 6, because this 12 cage, it would have to go with another 6. And that's not allowed, so this is... 3, 4, or 5, depending on this. Oh, and this goes here. I see. Right, and now this can't be a 5. So this can't be 7. So this can't be 8. This is 3 or 4, and this is 6 or 7. Okay, that's a 6, 7 pair. Alright, now, right, and these... Oh, there's also... Okay, one of these... I don't know which of these goes in here, but one of them does. So this is 6, 7, 8, or 9. This is 2, 3, 4, or 5. Oh. Okay, and I can keep going around here. Maybe I'll save these for later, because I know that this... And it's not 3, because... So that's not 8. This is 1, 2, or 4. Now... Okay, so one of these 2 goes here. Oh, neat. Yeah, that would be... Okay, that's as far as I can go in that direction, but here... Oh, I should look down here. Right, this is, Right, this goes here, and it's not 6. That is 7. So this is 6 or 9. Nice. So this is 2 or 5. This is 7. This is 5 to make 12. Oh, hey, Carl. Oh. Hey, Carl Martin. Welcome. Oh, and this goes here, so this isn't 4, so this isn't 2. Oh, and where does 7 go in this box? It goes there. I think I can get rid of that coloring now. Oh, hey, GDC. Welcome. So let me do the little sequence coloring over here. This is here. Right. Oh, and one of these two is here. Oh my god. Well, oh, that's... Okay. These have a difference of 3. These have a difference of 2. Oh, this goes here. Oh. And this can't be 3, 7. So this is either 1, 6, 2, 5, or 3, 4. That's not 5, so that's not 2. And this isn't 3, so this isn't 4. Oh, this isn't 5 either. These are the same. Now, if this... Oh. Wait, maybe I should be thinking about... This has to go in here, along with... Oh. Right, now that I've got 3 here, this is either 2, 6 or 1, 7. Right, and this can't be 1, so this can't be 7. Oh, and this also can't be 1. So this is a 2, 6 pair. And this is a 5, 9 pair. This is 5 or 9, so this is 4 or 8, I believe. So there's a 6 in here somewhere. All right. Oh, this has to go in here, so this can't be 4. This is 6 or 9. So this is not 6. Oh, and blue, in this column, neither of these can be 5 or 9, so this has to be blue. Oh, and this isn't 6, so this isn't 1. Right, so this is 1 or 4. Got a 1-4 pair here. I guess I have a virtual 5-9 pair here, because this is either 5-6 or 2-9. Maybe I should think about, okay, this, oh, wait, this is 4, 5, 8, or 9. It can't be 8 or 9. This is 4 or 5, and it's either here or here. If these are both 4s, that's 9, that's 6, that's... I should also think about oh, this can't be 2, 3, 5. Because then this would have no value. So this is 1, 4, 5. Okay, so this is 2. Okay, and this must go in this box. Nice. So here it's just, okay, one of these is a 1 or a 6. And one of these, well, one of these is a 3 or a 9. So I know it has a 1 or a 6 in it. And I know it has a 3 or a 9 in it. Oh. Except it doesn't have a 9 in it. So it's 1, 3, 4, 8, 1, 3, 5, 7, or 2, 3, 5. Okay, so there's always a 3 in it, and it has to go here. Ah, and there's always a 1 or a 2. Oh, there's also no 2 in it. So there's a 1 in it, and it's up here. So, okay, so these are 4, 8, or 5, 7. Oh, and there must be a 5 in it by sudoku. Okay, that's all the cages done as far as I can get them, so from here should just be sudoku. Okay, there's a 2 down here, so 2 in this box goes here. Ah, the 5 in this box, it can only go here. Gets me that. Alright, so how am I doing on 7s? Oh yeah, I added all the Pokemon through Gen 6. Those were the only... Gen 7 still not available on the workshop. Oh, 6 in this box. Goes there. Ah, which places it there. Ah, 9 in this box. Okay, 5, 4. Okay, that gets me... Am I done with 5s now? I think so. Nice. What's left in this box? 2, 3, and 7. Oh, there's 2. Oh, that just leaves 8 to finish the column. Let's see, there's an 8 down there. Ah, that forces 8 in this box. Three, 4, and 8. Ah, 3 in this box. Do I know 4 and 8? Apparently not. 2. Aha! I believe I'm done with 2s now. Yep. Ah, 1 in this box, or rather 1 in this column. 1 in this column. Leaving 4 and 8. Okay. That leaves a 4-8 pair here. What? Okay, 6, 7, 9. That's not 7, that's not 6, that's not 9. What about here? 3, 4, and 8. Oh, but 3 here. Okay, 3. And this is a 4-8 pair. pair. Gotta remember there's a 3. Oh, 3 in this box is done. Ah. Okay, that gets me 7 in this box. 7 in this box. 7 there, 7 there. I believe that's 7s are done. I should commission a custom sprite of rat fangs. Let's see, 1 and 4. Resolved by that. This row is 9. Oh, this column is done now too. 8. Oh, that's 4, which is going to resolve these for 8 pairs. Uh, 1 and 4. That leaves. Oh, that. Oh, no, not so. Oh, 9. 9. 6. That's 6. That's 4. That's 1. 8. 3. 1. 6. All right. Nice. Oh, no problem. Thank you for making it. I also saw, when I was searching for it, I found this one that also had it. I'll add that to my queue for Thursday. I agree with... Yeah, I think I agree with 1 star for difficulty, but, yeah, that was very nice. Alright, next up. Yeah, the Dutch flatmates one. It's also pretty easy. Might do that as my warm-up puzzle on Oops, hit the wrong button. Okay. Oh, cool. Something to look forward to then. Okay, pin this on YouTube. All right. This is a slightly different take on skyscrapers. Okay, so each purple shape is a building and its height equals the sum of the digits. Okay. Oh, lie scrapers. Okay. Okay, let me... where's that? Okay. Okay. So, normal Sudoku rules apply. So in every row, column, and each of these boxes, I got to put the digits 1 to 9 once each. skyscrapers. Each purple shape is a building and its height equals the sum of the digits in any cell it occupies. So, these are... The height of this building is the sum of the 2 digits. The height of this building is the sum of the 4 digits. The height of this is the sum of its 4 digits, and these are normal skyscrapers. Okay, yellow signs. In each 3x3 block, 2 buildings display a yellow sign. One accurately indicates the height of its building, the other is lying. So either these 4 cells sum to 7, or this one is 9, but not both. And either this is a 3 or this is a 9, but not both. Alright, and either this is 11, and either these sum to 11 or these sum to 11, but not both. And a white arrow indicates the number of buildings it can see in a straight line in the indicated direction. If a building further from the arrow is shorter than or the same height as a nearer building, then it cannot be seen, so is not counted. All arrows are truthful. So this is either 1, 2, 3, or 4, because it can see a max of 4 buildings. And if it's 4, then these have to strictly increase in height. So the sum of these has to be less than the sum of these, and this has to be higher than either of those, and this has to be highest of all, if this is 4. If this is 1, then this is the highest building in the row. That would be very tricky, but okay. And this same thing here. Alright. River. Road bridges separate the river into segments whose digits have the same total. So it's a region sum line. It means these 3 digits have the same sum as these 3, and they all sum to this. Okay, that's all the rules. So, let's dive in. Well, this is the sum of 3 cells in this box, so this is 6, 7, 8, 9. This can be a max of 5. So this being a 6 would be very restrictive indeed. I noticed earlier these can be a max of 4. In fact, these don't necessarily have to sum to 4, but they do have to sum to... sum to 5, sorry. These sum to 5 or less. Though I think they could sum... Oh no, because like... If these are tied for tallest, these could both be 1s, except, of course, that they're in the same row. This is a max of 7. This is a max of 3. Alright, and this is also a max of 4. Oh, this can't be 6, because then neither of these would be true. And in fact, is it possible this is true? No, because then... Right. Okay. The only way to have 3 cells without a 1 sum to a single-digit number is if it's 2, 3, 4 summing to 9. But that leaves too few digits here, so this isn't 1. So this is 6. Okay. Now, these can't be too high. Still, because they do have to sum to that. In fact, what's the max I can actually put on here? Well, wait. The max I can put on here is 6. And it can't be 6. Okay. Okay, that's a simpler way of spotting that. Okay, so this... So I guess this plus this sums to 16. 15, because it's the sum of 5-digit. Okay. These are 7, 8, 9. Oh. This can't be 1, because this, it's the sum of 4 digits, so it's always going to be higher than the sum of 2 digits. Okay. I think that only rules a 1 out of there offhand. What about... Right, this can't be a 1 either, for the same reason. So there is always a 1 on here. I guess this digit goes either here or here. This is a max of 6. And there's no... Oh. Can I do some arithmetic here? Like, I don't see much of a way to resolve this quite yet. That there is... I mean, I already know one of these is wrong. One of these totals is wrong. Of course, that doesn't necessarily mean that this is lower than this. Could be higher or the same height. Should think about this. If this is correct, 1, 2, 4, this is 3. But that would make this fairly low for a 3-cell cage, so it's not terribly surprising that this is 3. What would this be in that case? This would be 1 or 2. Is there anything wrong with that? I don't see anything wrong with that. What is... Okay, but if this is 1, 2, 4... This is 3. This would be either 3 or 5. Oh, and this would be a 3-5 pair. issue with that? One of these would be a 3. I guess these are also 1, 2, 3, 4, 5, and this is at most 6. This is also at most 6, so that's close to quad. This is also close to a quad. Now, where does the remaining... Do I know anything about where the remaining digit from 1, 2, 3, 4, 5 goes in this column? Goes in one of these. So if this is 1, 2, 4, this is 3. This is a 3, 5 pair. Huh. Think row 3, column 9 breaks if this is correct. Okay, let me think about this. That'd make this a 3. So this would have to be 5 or 6. Oh, but these... I would have to add something higher than these. Higher than... Right. Except this can't be higher than this. So this would never be visible. Okay. Yeah, that does break this if this is correct. Okay. I guess the max this can be is 5. Because this can never be visible behind this. It would be very tough for this to be visible behind both of these, so... What is... If this is 9, then this is 9. Does that break something? Okay, so I know this isn't 7. Can I narrow down what it is? Oh dear. One of these is the last. The other of 7 or 8 is also in here. I guess this is a max of 6 now. And if this is 6, this is 7, 8, 9. Is that... Does that break? I mean, it forces this to be a 9, which would make this a 1. Okay, yeah, this can't be 6 either. What is... It would be pretty easy for this to be high, honestly. But if this is 9, this is 1. None of these can be 1, so one of these would have to be the highest without using a 9. I mean, I still have 6, 7, and 8 to play with. If this isn't 9, this obviously can't be 9 no matter what I do. So, like, if this isn't 9, I mean, this is 3. If this is 3, then 9 in this box goes somewhere here. So if either of these are 1, like if this is 1, then there's a 9 in here, but this still has to be higher than that. If this is 1, there's a 9 in one of these, but this still has to be higher without using a nut. Is there some reason this... I mean, even if this is 1, this could be 6, 7, 8. Should make this 9. What is the, I guess 9 in this box, so it either goes here, which would be very weird, which would, would prevent this from being 22. Okay, if this is 2, no, it would force this to be 22. If this is, oh, maybe road 2, okay, maybe this being 1 breaks the other arrow. Oh yeah, because this is always going to be higher than single digit. Right, this can't be 1, because then this would have to also be 1. And I don't, yeah, this can't be 1 for the same reason. Okay, in fact, for these to be different, this has to be visible, right? So this is at least 7, 8, or 9. And the only way it's 7 is if both of these are 6. And this, oh, but these sum to at least 15. So this is like having 2 skyscrapers. Oh, wow. Okay. This does have to be 9. Because these skyscrapers that are at least, these are at least 15. Or, oh, right, yeah, this, right, this isn't 1. These are at least 15. In fact, do they have to be exactly 15? No, I guess they could be 6. No, but this has to be visible. It can't be the same height. These both have to be lower than 9. So this has to have a 1. Alright, bye, Stu. It's either 1, 2, 4. This can't be 1, 2, 3 because then the min this could be would be 4, 5. But it could be 1, 2, 4, or 1, 2, 5, or 1, 3, 4. Right, so this can't be 1. Or, oh. Right, okay. Alright, this is 1, 2, 3, 4, 5, or 1, 2, 3, 4, 6. So this is at least 5. Right, and these are a 7, 8 pair. So it's not possible for these to both be visible. Well, it's not possible for all three of these to be visible. Oh, that's still, but wait, I know that these are at least, I know that this is at least 7 or 8. Each of these is at least 7, and at least one of them is at least 8. In fact, if this is 1, 2, 3, 4, 6, these both have to be 8, right? So this is... Oh no, it is possible for this to be 7, this to be 8. This would be 6, and this could be... This could still be 5, okay. Oh, right, if this is visible from this direction, this has to be higher than it. So it does have to be higher than all of these. Oh, good spot. Right, okay, so this is higher than any of these. This probably is 22 in that case. I mean, it could just be anything higher than 9. Right, and I still can't actually roll out a max for these, but... Alright, this being 14 would be very pressuring for this arrow, but I don't think it's undoable. Alright, this has to be 8 or less. So this is, in fact, going to make a 1, 2, 3, 4, 5 quad. This isn't 1. Okay, and these sum to 7, so they're either 3, 4, or 2, 5. Oh, and the remaining low digit in this column, it has to go here. Oh, this is a 6, because it sees everything else. But wait. Isn't this exactly 1 more than this? Right, so this isn't 2. It's either 2, 3, 1, 4, 5. This can't be 2. Because 1, 4, 5 is too high. So there is a 2 in here. That rules 2 out of here. If this is 3, 4, 1, 2, 5, 8. But wait, that doesn't work. Because because more of these need to be visible. So this is just 4, 5. Okay, I was... And this is 7, this is 8. So these are, in fact... Right. So this is 2, 3, 4, 5. This is 2, 3, or 5. This is 2, 4, or 5. Oh, it's not 5, so that's not 2. And this is 1 with whichever of 2, 5, or 3, 4 isn't in here. Alright. Oh, this isn't visible. Oh, but I don't think this can be 2 either. Because I know this is the highest thing it sees. And this can't be 7, 8, or 9, or 6, so it has to be lower than this. So it sees this, at least one of these, and then this. So this is 3 or 4, depending on whether it sees 2 or 3 of these going this way. Oh, I think the only thing I'm tracking that, because I know this is 8. So the only question is, if this is 7, 8, this is 3. If this is 8, 7, this is 4. Okay. Now all of these are... Okay, so if this is 14, this is 13, 12, 11, 10. How would that work? I guess if this is lying, this is also lying. $13 without 9, 4, 6, 7. This would be 5, 8, which would make this 7. So if this is 5, 8, this has a 1. Is 1 placed in column 4? Oh, good question. Right, because all of these have to be visible. it could be here, 1, 9. Don't think the 14... Oh. "13 plus 14 is 27. Oh, these are only 6 digits, though, not 7. So I think 13 plus 14 is still doable. Yeah. That looked promising, though. And, like, okay. One in this column, I think, can only go here. That's... I can't resolve that yet, but that will doubtlessly be important at some point. There's also... Well, I know this is at least 13. So if this is 5, I know this is real and this is at least 16. If this is 1, and this is 2, oh yeah. Yeah. So I guess this is either 1 or 2, always. Well, if this is 1, then where does 2 go in this column? It can't go here, because if 1 goes here, it goes with 9 here. That rules 2 out of here, because it would have to go with at least a 9, even if this, regardless of which of these 11s is true. Then this would have to be at least 12, which would also rule out 2. Then this is at least 13. Yeah, so this is at least 10, this is at least 11, this is at least 12, this is at least 13, and this is either 14 or more. So if this is 1, then the only place for 2 in this column is here. Does that... I don't know if that made sense the way I explained it, but... 9 column 6 is not 7. Oh yeah. There have to be 2 different ways of making it. All right. Where? Oh, oops. Just grabbing a cough drop. Oh yeah, they can be the same sum, just not both 1, 2, 4. They could both be 1, 2, 5, like with a 5 here, and a 5 here, making the... Yeah, that works. Maybe I should think about 3 in this column. Doesn't it have to go here if this is 1? I think it does. If this is 1, this is 3. Now, what if this is 1? Then... I guess it could go in any of these. The minimum digit here is 4. Am I just gonna have to place 1, 2, 3 here with... Oh no. No, 1, 2, 3 here doesn't work. If this is 2, this is 1. Oh, then this could be anything that sums to 10. Because if this is 2, this is 9. I say. If the 11 in row 4, column 6 is correct, the 6 cells on the left are 33 max. Oh. Right, because these are 34. Right, okay. Okay, so this can't be 11, or else this would also be 11. So this is 11. Is it a 1, 2, 3, 4 quad in column 4? I think it is, because I can't put anything... Yeah, this is just a 1, 2, 3, 4. And this can't be 1, this can't be 1 or 2. And because this is 11, this is 7, 8, or 9. Okay, and because this is 11, this is 10. So this is 6, 7, 8, or 9. And this is 12 or 13, so this is only 8 or 9. Not sure what that leads. Okay, so this digit... Oh, hey, Isaiah. Welcome. Oh. 5 in this column must go here. With either 7 or 8. Okay, okay, so this has to be at least 13, and it can be at max 13. Okay, so this is 13. This is 12, this is 11, this is 10. Okay, so this is 4 now. Because it sees 1, 2, the 8 blocks the second 8 and the 6. Yeah, this is 4. Oh, and this is 9. So this is 9. So this is 1, 3, 5. Oh. 1, 4 needs another 4. This is 5. So this is 4. This is 8. This is 5. This is 1, 3. Row 5, column 9. Oh, yes. Row 5, column 9 is not 9 by anti-rook. So this is 7. All right. So 7 in this row. I'm guessing it's in here, but... Okay, so there's the 4 in this box goes here. Okay, this is a 6-9 pair. Nice. This is 10, 11, 12. So this is, in fact, 33. So these are 12. Right, so I know 1 in this box does not go here, or else this would actually be 11. So 1 in this box goes in one of these. Yeah, the color is a little... I mean, it shows up fine on my display, but it might... I should... been meaning to rearrange my OBS setup a bit. Okay, what about... Oh. Right. Oh, is? Oh, yeah. It's resolved by that. That's 1. Okay. I know this is at least 14. Oh, so this... Oh, wow. Okay. Oh, actually, no. Wait, hang on. It sees this, and this is the highest thing it sees. So, that doesn't actually tell me whether this is... is 14 or not. Because even if it is, this could also be 14 and this could be less. And if it's bigger than 14, that's fine. Oh, maybe this... Oh, I see. 5 in column... Oh yeah, 5 in column 5. This is 1, 2, 5. With that being 5, this being a 1, 2 pair. Right, it's a right. This is 12 in 3 cells without using 3, 4, 8, or 9. Oh. Uses 1 of 6 or 7. 1, 5. Oh, 1, 5, 6. Okay, so 7, 8, 9. This isn't 6, so this isn't 4. Okay. And this isn't 5, 6, because that's 11, so there's a 1 in there, which makes that 5 or 6. Alright, this isn't 3, because that breaks this. I should look, wait, if this is 4, oh no, that's 3, 9, 4, 7, okay, that works. What about this? 2, 8, 4, 7, 3, 9, okay. What about 3, 7, 4, 8, 2, 9, okay, so we're down to everything, okay, everything works here. Okay. What's left in this column? 3, 4, 6. And what's left here? Oh, this has to be 7. Oh, this can't be 14 now. The minimum it can be is 15. Okay, so this is 6, which actually makes this 15. Okay. Oh, and that's 2. Which Chad already pointed out. Okay. Okay. Okay, this is... Right. Ah. I think this clue... Right, this is 15. So neither of these can be higher than 15. So either this is lower than 15, or this is either lower than 14 or exactly 15. Ah, but for this clue to work, if this is lower than 15... Oh no, it could be 13. Okay. Yeah, this one, if this is low enough, it's just not visible. The 11 in column 4. You mean this? Doesn't this also work with 4, 7? Oh, 11 in box 4. Yeah, this is a 7. Right, it can't be 5, 6 or 4, 7. Oh, and it can't be 3, 8 without breaking this. Okay, so if this is correct, it is 2, 9. If it's not correct, then this is a... Wait, if this is correct, it's 2, 9, which would make this 4, 8, 3, 7. If it is correct, this is a... And if it's not correct, then this is a 7. Which would make this 2, 8, 3, 9, 4, 7. So either way, the 7 in this row is only here. Don't know how useful that is, but it is interesting. This is... oh, what's left in this row? Oh, 8 and 9. That's easy. Oh! Welcome, Raiders. How was your stream, Jojo? Hi, Soder and Jobo. Nice. All right, this is 8 or 9. So, wait, if this is correct, this is 2, 3. Oh, this can't be correct. Because if this is 8, 9, this is 2, 3, which makes these both 1s. Because I've used up 1 and 4. Okay, so this is correct. Neat. Okay, and what is actually down here? That's 6, 7. All right, and this is 3 and 5. Oh, 14 being correct in box 7 makes the 15 cage higher than 15. Let me think about this. If this is 14, then these sum to 31. I think this could still technically be 14. Oh, no, but this can't be 8 or 9. Right, so if this is correct, this is higher than 15, which doesn't work for this clue, which breaks this clue. Okay, so 14 is not correct, so 15 is. I'll just notate it that way. Let's see. Where is... Oh. So, 15, and I can only use a max of 2 high digits. Oh, does it have to be... Oh, right, yeah, because this is 30, so if this is less than... Or, yeah, so this is 2 15 cages. So these sum to 15, with this being 7 and... Ooh. I think this could technically be... Oh, yeah, this is 7, 8. Wow. Okay. What's left in this? 3, 4, and 5. That's not 4. Oh, and 1, 3, 9, I believe. So this is, where is... Oh, hold on just a sec. An old friend of ours just got in for a visit, and I was saying hi briefly. I'll hang out more after the stream. Let's see. So I know there's a 9 in here. I'm guessing it's here because, like, okay, if this is 3, 5, that's 8. This would have to be at least 7, which it can't be. Yeah, this has to be 9. Okay. Okay, I see where this is going. Okay, so these sum to 6. So that's not 3. That's 4, 5. This is 1 or 2. So they're 1, 5, with this being 2. Oh, wait, no, if this is 1, 5, these are both 3. That doesn't work. So this is 2, 4. Ah, 1, 3 pair there. What else is... Oh, it's 1, 3, 6. Oh, it doesn't resolve these. It's not 1. Yeah, it could be a refreshing change. Oh, the one in this box that looks up here. Rolls 1 out of there. Oh, I haven't thought about this in a long time. I believe that's the only remaining clue that isn't the only remaining arrow clue that isn't basically resolved. I guess I can get rid of this coloring now just to get a little more. Uh, oh yeah, the 2, 9. It rolls the 11 out of there. Nice. That's 3 now. Ah. So, 5, 3. Oh, yeah, 2, 3, 4, resolved by the river. All right. So this, oh yeah, 1, 8 pair here. So that is, 1, 6, 6. Oh, 1 in this row. And leaving a 6, 9 pair. Nice, to complete the row. Okay, this is 15, and all of these have to be visible here. What's left in this column? 2 and 8. That's 2. That's 8. And what's left up here? Oh. Ah, 1 and 5. So that's 1, that's 5. Ah, okay. This... That's 4. Ah, and 6, 9. Nice. Deadly pattern, which is resolved because this can't be... Yeah. Nice. Yeah, skyscraper cages. I think I remember some other puzzle like a long time ago doing something along those lines. I can't remember much about. But yeah, that was neat. I would say the break-in, most of it I would agree with 4 or even 3 stars, but that break-in I think might push it a little higher. I'll say I agree with 4 stars for difficulty overall, but yeah, that was neat. Yeah. Love the aesthetics too. A worthy intermezzo between rat run seasons. Yeah. I agree. That was neat. All right. Next up, got Zeta Math's new puzzle, and then Sniglet asked me to check out this genre intro thing. Yeah, I will. Okay, that looks pretty straightforward. I will ping Zeta. Oh, I got some other. All right. Now to where is? Oh, neat. Good to know. Oh, there it is. Alright, so I pinged Zeta. Alright, let's dive in. Okay, standard lines for 10 lines. For entropic. Okay, I'll go in order. Well, normal Sudoku rules apply, so every row, column... Oh, hi, Zeta! Welcome in! Every row, column, and box, I gotta put the digits 1 to 9 once each. What's this white line over this? Some of these, oh, is that just for aesthetic? Oh, because of ladder. Oh, is that for the ladder aesthetic? Not really. No real preference on which chat anyone uses. Though you might have well, I mean, you can still see the chat box above my head on the stream. I think most people are still on Twitch, but I wanted to give people more options. Alright. Okay, so entropic lines, every 3 digits along an entropic line must contain one low digit from 1, 2, 3, one middle digit from 4, 5, 6, and one high digit from 7, 8, 9 in some order. So that applies to these 3 and these 3. Which means these must be the same entropy, because you can sort of do entropy coloring along any line longer than... Right. Oh, I see something going on here. Nabner lines. So Nabner lines are simple. No 2 digits anywhere on a Nabner line can be the same or be consecutive. So digits can't repeat on a Nabner line, so this can't go here, but also no 2 of them can be consecutive. So if I put 3, I then can't put another 3, a 4, or a 5 anywhere on that Nabner line. German whispers, so any two adjacent cells along this line must differ by at least 5. So these must be at least 5 apart. So if I put 1 here, these both have to be from 6, 7, 8, 9. 10 lines. Okay, 10 lines. I must divide these into each of these lines must be divided into non-overlapping groups that each sum to 10. So, for instance, I could make these sum to 10, these sum to 10, and these sum to 10, or these sum to 10, these, and then these, or these, and then these, if these sum to 10. Okay, and black dots, that means one of these 2 digits is double the other. So if I put 2 here, I must put 1 or 4 here. Oh, these rules don't mention Renbans, but a Renban line must contain a non-repeating set of consecutive digits in some order. So these must be a run of 3 consecutive digits arranged in some order. So it could be 1, 2, 3, 3, 4, 5, or 7, 8, 9, or something like that. Same with this one. Okay, that's all the rules. Well, what I'm looking at here is this entropy... Hey, I've been there, believe me. This entropy and this entropy, they each contain one low, one middle, and one high. So these must contain one low, one middle, and one high. And you can never put a 5 on a German whisper, because it would have to go with either a 0 or less or a 10 or higher. So the middle digit on here must be 4 or 6, and it must go... Oh, it could go here, because these could be the same. Well, I guess this can't be a 4, because this can't be a 9. Okay, that's not quite as powerful. Oh, I have the same thing here. Ah. And these... Okay, I think these have to be a 1-9 pair. Because one of these is a 4 or a 6, and if it's a 4, it makes that a 9. And one of these is a 4 or a 6, and if it's a 4, it makes that a 9, and if it's a 6, it makes that a 1. Oh yeah, it's also mentioned on here. Yeah. Figured it would be. Let's see. Alright, so what I got is... Okay. So I gotta remember, these have the same entropy. Right, and... So either this is a 6, or this is a 4 or a 6. If this is a 6, these are both 1s. Does that... Where else do I start? Well, this Nabner. This Renbon and an Entropic line and a Nabner. Okay, that is fairly restrictive. Obviously, these can't be all the low digits, all the middle digits, or all the high digits. Can't be 1, 2, 3. Can't be 4, 5, 6. It can't be 7, 8, 9. So this can't have a 1 or a 9 on it. So this 1 or 9, it has to go on here. I should also start marking up these 10 lines because I know that those are part of a sum. I don't know whether this is part of the same sum. I know this. These are either a full sum or part of one that includes this. I suppose it's possible. Wait, it's not possible for these to be 2 4-cell sums, right? I guess digits can repeat on a 10 line if allowed by other rules, so I guess 8-cell 10 line. This is... Each 8-cell 10 lines, okay. I guess this will always take 2 of one entropy and 1 of another. So I guess if this is like 2, 3, 4, there's a 1 on here. If this is 6, 7, 8, there's a 9 on here. But it doesn't, it could be 5, 6, 7. It's possible for there to be neither a 1 nor a 9 on here. Oh, I can also do polarity coloring, because German Whispers, alternate digits have to jump across the 5. Oh, it's the labels. That's why these white lines are here. Oh, okay. I see. So there's the fact that yeah, Sudoku Maker does let you make the cages invisible. So the high digit on here is 7 or 8. These have the same entropy. What does that mean for... Oh. Okay, well, 5 in this row can only go here. So at least one of these is not a 2-cell sum. In fact, the 5 in this row goes on here with specifically a 2, 3, or 4. And goes with a 1, 2, 3 either here or here to complete the sum. Ooh, unless it does something fancy like 2 1s here or something, because if digits can repeat, it's possible for these to sum to 5, or like these or these to sum to 5. Something fancy? Or... oh. Maybe I should think more about this, because, like... okay, say this is 2, 3, 4. Something oh. Oh, I see. Okay, if this is 2, 3, 4, then there's a 1 on here. This would be 5, 7, 9. So this would be 1, 6, 8. So if this is 2, 3, 4, this is 5, 7, 9 with like a 1, 2, or 3 down here, and 1, 6, 8 here. If this is 3, 4, 5, there's a 6 on here, 9, 7, 9 and 7 here with 1 or 2, so there's a 6, 8 here, and the low digit is 1 or 2. So, so I guess if this contains any digits below 5, there's a 9 on here. If this contains any digits higher than 5, by symmetrical logic, there's a 1 on here. And a 3. So this always has either a 1-3 pair or a 7-9 pair. So this is never from 4, 5, 6, or wait. If this is 3, 4, 5, 7, 9 with 1 or 2. Yes, this would be from 3, 4, 5. Yeah, this could still be anything. Okay. Maybe I should do, like... Hey, if this is 2, 3, 4... This is 1, 6, 8... This is 6, 7, 8. This is 2, 4, 9. I'm wondering if I should act as though I have resolved the polarity, and if I reach a contradiction, I can just reverse the polarity? Or am I missing something more obvious? Oh, the horizontal part of the ladder is row 5. I'm guessing that's it. Okay, so like, there's no... Right, there's no 1s or 9s on here, so there's no 4 or 6 either. So 4, 5, and 6 in this row all go there. I think this has to be either 2 or 8, right? Yeah, because it's going next to either 7, 8 or 2, 3. So, oh. So, 4, 5, and 6 in this row all go here. I guess I have a virtual 2, 8 pair here. Oh. But wait. If this is 2, 3 with 8, 7 also goes on here with 4, 5, 6. That's too high. Okay. Okay, 2 is ruled out of there, so 1 is also ruled out of there. So this is either 4, 8 or 3, 6. Okay, and this is 3, 4, 5, 6. Now, I suppose it is possible for, like, these to both be 1s and for neither of these to be a sum. Oh, but wait. Right, in fact, that has to be the case. Because if one of these is a 4, 6 pair, the other is a 3, 5, and it either... Oh, this could be a 3, 5 with a 2 here. This can't. Okay, so if this is 4, 6... Right, okay. Actually, if this is 4, 6, what do I then do up here? Suppose that could be 9, 1. Or another 4, 6 for that matter. Okay. What is this? I should get rid of this coloring, or... yeah, 5, 2, or 1, 1 for that matter. What is... Oh. Could these both be 1? Okay, if these are both 1s, then that's 1. Wait, this can't be 4, 6. Because this can't be a 2 or 2 1s. So this can't be a complete sum. So this sums to a max of 9. And a minimum of 8. So this is 1 or 2. If this is 1, this is 2, this is 3, 5, this is 4, 6. This could be 2 in that case. This is... Oh, right. Because the entropy tropic line. Right, and if this is 9... Wait, if this is 1, this is 2... but then these are high. Oh. Wait, if this is 1, this is 2, then... Oh. Right. I can't put a 4-6 pair in either of those. Right. Okay. Okay. So, I think these both have to sum to not right. Right, so this is 3-6, and this is 4-5. Oh, and this is a 2-4 pair now. I don't think I need the coloring now. This is less resolved, but this is still... Okay. One of these two takes this. Alright, now can this be on its own? It could be 4-6. Could just barely work. Oh, there's... That is... Oh, this be 2, so can't be 4-6 or 1-9. Be 2-8 or 3-7. This being... Oh, but wait, now that I can't have a 1 on here, this can't have any digits higher than... This is... There's always a 3 or 4 on here, so there's always a 7 or a 9 on here. A 7 and 9 on here, so there's an 8. The high digit on here is an 8. Oh, and I think the middle digit, isn't the middle digit always a 6? Oh, it's 168. Because the 2 and 4. Six, 8. Seven, 9, and either 2 or 5. But the 3, okay. So there's a 6 up here. If it's 2, 7, 9, this is 4 or 5. And if it's 5, 7, 9, this is 1, 2, or 3. Oh. Well, that also gets me 3, 5, 7 here. So these can only be even. So I don't think... In fact, all of these can only be even. So this has to be a single... Okay, and this is part of this. So this is an 8. Either 2, 8 or 4, 6. Oh, but either way there's a 2 up here, because if this is 4, 6, this is 2. Don't I? Because these are all even. So if it's a 3-cell sum, because they see 1, 3, 5, 7, and 9. Oh, neat. Alright. This is an 8, because these can't both be 1s. And there's always a 2 up here, so that's... So that is 5, 7, 9. Oh, this is 8. That's a simpler way of spotting that. Okay, so these sum to 8 without using 1 or 2. So it's 3, 5, right? Okay, so 5 in this box goes here. Oh, and that's just 7. So that's 6 or 9. Nice. This is 1, 8, 9. All right. This is 4, 6, 9. Oh, that's a virtual 4-6 pair. I don't think that's too useful. I guess it rolls. So I know this isn't 2, 4, 6, or 9. What about... Oh, where does 4 go in this row? Oh, also the 4, 6, 9 resolves the... Okay, okay. Oh, that's not 6, so that's 6. Okay, so this isn't 9, so this isn't 4. What's left in this row? 3, 7, 8. Oh! Well, that's forced. 3, 7. Okay. 2 and 9 here, I believe. Okay. Alright, so this becomes part of this. Right, so these sum to 10. Could still be 2, 3, 5. Oh wait, no it can't be, because that uses up all the low digits, and then the centropic line can't have any lows on it, which would be bad. Yeah. Alright. So there is a 1 on here somewhere. And that's the only low digit on here. So this is 1, 4, 5. So there's a 2 or a 3 on here. All right. Oh, okay. That's not quite resolved yet. Okay. There's also a 6 on here somewhere. Oh, and right, there's a virtual 4, 6 pair. So this 6 looks up. So this isn't middle. Do I know if it's high or low? I know this isn't 1 or 2. Could be 3. This is 3, 7, or 8. Now, if I could somehow rule 7 out of here, that would create a virtual 3-8 pair here, which would give me 5-1. If this isn't 7... Wait, this can never be 3. Oh no, wait. If this isn't 7, this is 2. Okay. So if this is 2, this is 7. If this is 3, this is low, and there's a low on here, which would make this a 4-8 pair. That's a 2. Then that has no value. So it doesn't work for this to be a 3. Okay, so this is high. Okay. So this is 2, 3, 6. Oh, and there can never be a 6 on here, because if this is 6, this is 2, 3. My internalized black dot rule now is every black dot has at least one of 2, 3, 4 on it. Ah, yeah. That's also helpful. So that's a virtual... Okay, I can go further with that. So one of these is 3. This... In fact, this can't be a 2, 4. So this is 1, 2, or 4, 8. That creates a virtual 1, 8 pair. So that is 7. Oh, 8 in this box, which in turn gets me quite a few things. So that's... Oh, there's a thing. Okay. I guess 8 in this box goes either here or here. Oh. does the remaining digit from 2, 3, 4 go in this row? Has to go there somewhere. What is that? Oh, it can be here. Okay. What about... I guess this can't be 1, 2, 3, or 4. Wait, this is only 5 or 9. Okay, so there's... there is. 1, 2, 3. Oh, yeah. Right. Should have got that quite a bit sooner. Ah, 6 in this box. X-wing on 4, so the middle digit up here is 4. Do I have something? There's... I guess 1 in this box goes here, so one in this box goes up here. Now, if this is... There's a 1 on here, that's 2, 3. Oh, that doesn't work, because that breaks the entropy line, so that's 1. Okay, so... So there is... I guess there could be... If there's an 8 here... I guess 5 and 3 are the others? That Right, so the middle digit down here is 5. Now, ooh, okay. Where is? Oh, one in this spot. Okay. That has been resolved for quite some time. Is that all the ones? Almost. Got an X-Wing to finish them off. Alright. So the low digit on here is 2 or 3. Same with here. Well, what's actually left in this box? Oh. Where does the last low digit? In here. Right, right. This is a 2-3 pair, so that's 2 or 3. Oh, that 4, 5. Remove. Okay. Alright, and that's 5, 7, or 9. Oh, that 5. Okay. X-Wing on 5s. What about this as that's even less restricted. Alright, but this does go on here specifically. I looked at that earlier. Is this okay? If it has a 5 on it, it's 5, 6, 7. Would that break something? know it doesn't have a 9 on it either. Oh, so what does that leave for... In fact, I know it doesn't have any low digits on it. So it's either 5, 6, 7 or 6, 7, 8. So there's always a 6 on it. So that is 7. That's not 6, so that's not 3. Oh, that's also not 6, so that's not... Oh, that's 8, 4. Okay. So this is 2, 3, 9. One of them is a 9. This is... so this so that's a 6. And this, oh, that makes this a 3. Ah. Oh, this can't be 1 or 2. This can't be 1. So it's 8 or 9. Okay, that's 9. What's left in this column? It's 1, 5. Leaving 2 and 7 here. Oh, that forces that to be a 7. Oh, which makes that a 5, which in turn is going to resolve most of this. Yeah, that's going to get me this. All right. It's the stables from Breath of the Wild, which I think is sort of, it samples heavily from the Ocarina of Time stables. All right, good night, JoJo. I might go 1 star higher on that, but yeah, that was nice. And this is Majora's Mask soundtrack. Yeah. Yeah, Lon Lon Ranch. It does have quite a few things. Yeah, it does sample the Epona's song. It shares yeah. Alright, let me ping Sniglet. Oh, no problem. Thanks for uploading it. I do need a break to refill my water first. But I will be right back, and then I will try out a totally new puzzle genre. Let's see, pin this, switch. Okay. Alright, I will be right back. Just a couple minutes. Ah. Alright, sorry, that took a few minutes longer than I thought. Wanted to say hi briefly to a friend who's visiting before I came back here. Well, okay, yeah, this is a new, this is Sniglet's attempt at designing a new pencil puzzle genre. Included an example puzzle to help understand the rule set. Move some shapes vertically and horizontally and draw a line through the path taken, such that every cell is either a shape or path cell, and no two similar shapes can see each other vertically or horizontally. Okay. Oh, Chameleon implemented it in Puzzle TV. Neat. Of course, my rules resizer script won't work, but path cells cannot intersect and shapes block vision of each other. Oh, shapes block vision of each other. Okay. Black shapes must be moved, not featured in this puzzle. See example. Oh, okay. Okay, so let me... Let me try the example puzzle. Simple rule set. Simple enough rule set. Move some shapes vertically and horizontally and draw a line through the path tag. Okay. So, how do I go about this? At least one of these has to move. Oh, it draws a path for me. Okay. Still the rules. Okay, maybe I should start here. Oh, a digit in a shape defines the exact quantity of cells that it will move. Ah, yes, that's here. Okay, so the 3 has to move 3. Oh, I haven't been paying attention to YouTube chat at all. That's what the... Ah, okay, yeah. So this has to move 3. So the only options are to move here or here. Now, if this moves 3, right, paths can't overlap each other, so now this one can't move. Okay, so that's the break-in. Okay. So now this... Okay, if this moves down, this one can't move, and they see each other. So this moves up, and now this moves up. Now this has to move there, and this has to move there. I think that's... Yeah, every cell is either shape or path, or both. And they block the vision. I think that's it. Yeah. Okay. Okay, that's an example. All right, let's see this. What is this? Okay, now for the full puzzle. Oh, hey, juggler. Okay, so one of these has to move. One of these has to move. One of these. Well, I know this has to move. How can this move 3? Right, and shapes can't travel over other shapes' starting positions because those either the shape stays there or it becomes a path cell. So these are all blocked off from this shape's movement. So this shape winds up either here or in this column somewhere. In fact, I don't think this shape can wind up here, because parity. Right, yeah. Wherever this winds up, it must be... This shape can only wind up here, here, or here. Similarly, this one only winds up in one of these. Oh. But how does this cell wind up as a shape or a path cell? One of these has to move into it and just stay there, and it can't be there. It can't be that one. Okay, so this one can't wind up here. So it winds up here or here. So I know this shape winds up here at some point on its route to either here or here. But I don't know that it winds up here because it could go like that. It goes like that, or like that. So either way, this one does wind up here. Oh, but wait. So if this moves down, oh, these could wind up here. Wait, that doesn't work. I don't think it works for this to move down. Because, like, wouldn't each of these have to wind up here? That's a little look-aheady, but... And if these wind up here... there's no way for this needs to move up. And now... Ooh, maybe this one just doesn't move. I think that does actually work. Okay, so I should probably start with... Yeah, exactly. But which circle is it, is the question. Could be this. I know it's not this one because it can't, path cells can't intersect, so it can't move 3 and wind up here. I see one way this could work for it to be this. Just one, but... Does it, though? Like... Well, let me bifurcate this. Like, if that moves down... Oh, that... Yeah, that doesn't work. Because this moving and this moving, yeah, that... Right. This moves either here or here, and this... Basically, these wind up swapping corners. So one of these, so these two cells, these two shapes wind up here. So it doesn't work for this one to move down. And the reason this has to move here if this moves down is because of this moving 3. I drew in some X's to quarantine. Yeah, I can just sort of do that. Yeah, that would be smart. Now, okay, so this can't move down because this, it needs to end up in one of these. And if this moves down, then these two are going to block all of that movement. So, this... So where does this... This has to move... Oh. Right, well, it doesn't matter if this one moves out of the way. This one can never move here because that would still be a path cell. So this one can never move up. It has to move there. Okay, that forces this. Oh, and now this either stays here or moves here, and either way, this doesn't move up. Okay, took me a second to spot the, Right, and now this has to move there to make this cell be part of the thing, and now, right, yeah. Right, and now this, there. Yeah, no two of the same shape see each other without a different shape in the way, and every cell is either the path. These moved 3, these moved 1. Yeah, that's it. Okay. Coordinates, letters for rows, numbers for columns. Oh, okay. Okay. A3, B5, D1, E2, I think is the example for this. Yeah. I'd go 2-star, but yeah, that is very... Alright. Alright, let me try one more of these, see if it's a little trickier. Slide and seek the black sheep. Okay, this one's 2 stars. Okay, well, now that I've got the hang of it. Alright. Okay, and here... Alright, here it's the same, but black sheeps must be nameless sudoku. I don't think the rules got filled in properly, but it should be the same. Okay, and black shapes must move at least 1. Alright, so, well, I can just... Okay, well, I know this one goes here, and it moves 1 more in some direction. Now, this one can't move at all. So this one can't go here, or it would always see that. Ah! So it has to keep going up. Okay, now this one has to move. Okay, now this one can't move. So this one also has to move. And this one also has to move. Okay. Now, what is this? Oh. What moves into here? It has to stop once it does, so it can't be this. So it's one of these two. I mean, I'm seeing something that would... work very well. Yeah, that'd be fine. Okay, but does it have to be that? I just did a whole long chain in my head that looks correct, but is there a reason it has to be that? Oh, wait, no, that wouldn't work because then this... Okay, oh, maybe it's... Maybe I should think about, like, what reaches here? Where? Oh. Oh, is it what reaches here? It's gotta be one of these, right? Oh. Is it... Huh. I see a whole bunch of moves I could make. Let's see, I know either this or this goes in here. Now, if it's this... Oh, wait, if this goes down here, what takes this cell? It's got to be a circle, but it can't be. Okay, so this goes up. Okay, and I don't need... Okay. And what takes this cell? It can't be a circle, or... Oh, no, because this one has to move anyway. Okay, but now this... Okay, this can't... This has to go here, or else it will always see this. So now this one has to move... Oh, what takes this? Only this one can. So this one needs to get out... and go there. Okay. This was the first part of that huge chain I saw. Glad to know that that is actually required. Okay. What takes this cell? It can only be one of these. Because if this one... This shape can't move, or else these two will see each other. So, how do I... Right, and neither of these two shapes can't end in the same column, and neither of them can end in these columns, so one of them has to make it down here. In fact... Oh, and that's going to force this. Okay. So one of these... Wait. Maybe not. Because what takes this? True. Oh. Gotta remember, this can also move. So, one of these has to escape through here. Because otherwise they're going to be in the same column or share a same column with these. But I may have made a mistake in getting here. I mean, I can see... This seems to work, except now these see each other. Do... Am I... Oh wait, what? Just the example... Okay, the example... Black and white don't see it. Maybe I made a mistake somewhere earlier. That row 2, column 5. Okay, let me. Okay, so we start with this one going up, and now this one can never move, so this one has to keep going up. Okay, now if this goes down, then what takes this cell, I think, was the argument. Yeah. Right, so if this goes down, then one of these two has to move into here, and now these see each other in the end. So this one can't go down. And since this one can never move, this one can't go left. So what takes this cell, it has to be this one. Now this one, now this is forced to move like that. Now, what takes this cell? It has to be, if it's this, then this one can't move and it's right next to another of the same shape. So this one has to go here. Now this one, it has to keep going, and since nothing can enter this cell, since this one can't go up now, once this is moved over here. Okay, so I was correct up to here. Oh, wait. Well, but paths can't overlap each other. So, like, once this moves here, where does it go from there? Because, like, if this moves down here, this has to keep going, but now it can't go anywhere. And even if this moves out of the way, it can't take the same cell. I'm not explaining this very well, but if this moves down... Well, this could come up from below, but now these see each other because this is out of the way. Because now that I've moved this, it's no longer in the way. So when this goes up, these see each other, and now this can't move because paths can't overlap. Like, this can't move here once this is moved. Like, no shape can move onto any cell that another shape has been on. Yeah, that... Okay, so... Yeah, this... All this is forced. So... Now what? Well, actually, wait. Let me double check this. This has to move. And if it moves up here, it can't enter any of those cells. So it does have to move here. And nothing can enter it. Like, I can't move this down here for a number of reasons. So, yeah, this is forced. And now, what takes this cell? The same logic applies. It has to be this. Oh, I should also start the sudoku pillar loading to handle after this. So this has to be here. Actually, wait. Is this for... Yeah, this has to move, because these are done moving. So this has to get out of the way, and now it has to arrange it so it's not seen by that, which puts it here. Okay, and since this never moves, this doesn't move. Okay, so this is all forced, because this has to move too, and it can't enter any of these cells. Okay. Oh. I see what's going on. Wait. Oh. Oh, that works. So this could go down and take a bunch of other cells, except if this goes down, this can never leave. Oh. Actually, wait, no, it's not stuck. I see what happens. I was thinking this was stuck, but no, this does this. There. Oh, but now these see each other. Oh, dang it. Oh, wait, no, I see what to do. This goes down here, and now this goes here, and this goes there. Okay, it was this that was tripping me up, because I thought this was stuck when it wasn't. Ooh, dang it. Right, good point. Ooh, okay, so this is stuck. Which means we're right back where we started with not being able to... Huh, yeah, this one... Huh. This one... Okay. Okay, well... I know that... These can't both end up in this column, so one of them does, and they can't, and neither of them can end up in this column. Yeah, exactly. That's where I was at before. And now that means this has to go here. Exactly. But what takes this cell? Oh! Wait. Oh, but now these... Wait. Wait, that's it. Oh, okay. Oh yeah, I could have marked a corner here. Maybe that would have been easier. Yeah, it probably would have been easier to spot that. Okay. Okay. Nice. Let's see. B3, B6, C2, C5, D6. Okay. I think that is the... Yeah. Trying to find the way to say things that isn't I tried it and it didn't work, but that is always very hard in a new genre. But yeah, that is... I'm surprised this cell had to be shaded. I'm surprised this circle had to be shaded, because I think, like, wasn't it moving force just... Or maybe there was a way to solve to... Like, if this was hollow, wouldn't the solution have also been forced? Or... Yeah, by this. Maybe it wouldn't have been as easy to spot, though. Alright. Might go higher for difficulty, but yeah, that is... Okay, I will definitely be trying another of those next week. Well, Thursday, not next week. This week, Thursday. I've also got this in the queue for Thursday, as well as this and that. Alright. But for now, I think I will finish up with another column of the sudoku pillar. Alright, I will... I'll ping Meme Rister's server. Oh, thank you for the subscription. I've pinged Memerister's server. Yeah, we're getting close. I love how the it sort of creates a little loading bar. When I tab away and come back, a little more of it is filled in each time. Oh, in fact, I might get to Zeta Math's puzzle today. Yes, in fact, I think I will. Because, yeah, it's third in this column, if I believe. Ooh, a gap. That's going to be interesting. Oh, there we go. Alright. Fingers by Rubik's Cube. Alright. 6x6, Renban, and Kropke dots. Alright. Alright, so, well, this needs a 3 and a 4 on it. So I guess one of these has... Yeah, a 4-cell Renban in 6x6, it needs a 3 and a 4. And none of these can be 3, so one of these has to be 3, so this can't be 3. Oh, that's cool. Alright, so there's a 4 down here. Oh, and there's no 6 on it. So it also needs a 2, which has to go down here. And this is 1 or 5. Oh, the input lag. But I'm too deep in now. These have to be even. So there has to be an odd digit in between them. Oh, and I think one of these has to be 4, because these have to be exactly 2 apart. So this is either 3 or 5, basically. Okay. Yeah, there is... Okay. Oh, what's down here? Oh, 1 and 5 to finish off the column. Okay, so there's a 2 in here, which makes that 6. So that is 3. And you can't put 2 and 6 on a 4-cell Renban, so the other thing down here must be 4. So there's a 3 here, which rules it out of here, which places it there, along with 1 or 5. Oh, that's a 1, 3, 5 triple. So there's a 6 here, 6 here. Oh, this can't be 6 because this can't be 5. this still could be 5. In fact, it is 1 or 5. So if that's 1, that's 2. If that's 5, that's either 4 or 6. Oh. 4, where does 4 go on this Renbon? It's there. Okay. That resolves these. Getting more. Oh! That doesn't actually resolve this 6, but we're getting close. Oh, this is also 1 or 5. The 3 on this Renbon must go here. Do I know what the other digits are? I know it can't have both 1 and 2 on there, because they both have to go here. In fact, it can't... Oh, it can't have a 2 on there at all. Okay. Okay, so it's 3, 4, 5, 6. So it's 3, 5, 6. That's 1. Oh. 2, 3. Ah, that's 3. That's 2. So that's 3. That's 5, 6. Okay. How do I resolve this? This is... This is 2. Oh, this is... Oh. Oh, this 1. It looks up. Duh. There is... There is... Oh, this 6. That's 2, that's 1. Okay. Triangulation by Damassosos, 92. Okay. Okay, so these are modular lines. So they have different remainders when divided by 3. Digits may repeat on these lines if allowed by other rules. Okay, and they're also region sum lines. A line within a box does not have any implications for region sum rules. Okay, so this is just a modular line. All the others are both modular lines and region sum lines. All right, what is the minimum this can be? Can't have 2 or 4. The minimum this can be is 1 and 3, so the minimum this can be is 4. Can't be 4. This is 5 or 6. Oh, and it can't be... Oh no, it could be 1, 3. Wait, if this is 5... Yeah, this can't be 5. Because This can't be 1, 4, or 2, 3 just by sudoku, let alone by... Okay, I could get this just by... region sum, and it's got to be... Well, it's 1, 4, or 2, 5. But, no, sorry, it's 1, 5, or 2, 4, and it's not 2, 4. It's 1, 5. And this is 3. I think I did that without even... Okay, so this is 1, 2, 3. Oh, but now is when the modularity comes into play, because these cannot be 3. This is 3. Okay, that's 3 in this box just by sudoku. Okay, the remainder of 2, the digit with a remainder of 2 on here is just a 2, because 5 is taken in the column. And this is 4. Because these are 2, 4, 6. This sees 2 and 6 in its column. Okay, so this is 2, 6. This is 4, 5. And this is 1, 2. Okay. Got a bent X-wing on 1s here. Oh, there's also this. I haven't looked at this much. This is 4, 5, or 6. Now, I don't think this can be 4, because 1, 3, 4 breaks the line. Now, if this is 5, 5 also breaks the modular line. Okay, this time it doesn't break by region sum. Okay. This is 1, 2, 4, 5. This is 3, and this is 3 by sudoku. So these are the same 2 digits. So those are... Oh! Well, I can resolve 4 and 5 here. Okay. That gets me a 1, 5, 1, 2. Oh, this 6 also resolved this. Okay, so either this is a 1, 5 or 2, 4. Oh, interesting that I know the modularity here without actually knowing the equation. Okay, so 5 in this box. Ah, that resolves it. Ah, this is this digit, and it's not a 4. That's 1. That's 6. That's 4. That's 6. That's 5. 1. Okay. Oh, I forgot to... No, Damascus didn't... Okay. Next one is right after Zetas, which I believe is next. Bait. Yep, it's Renban and Cropgate. Only this one with a single dot. Which you don't even need to make... Which you probably don't even need to make it unique, but it's Zeta Math signature, so I like it. Okay. This 2-cell Ranman can't have a 3 or a 6 on it, so it's either a 1-2 pair or a 4-5 pair. If this is a 6, this is a 4-5 pair. Oh. These, I can use the horizontal roping. These are... So we have vertical roping in these columns. So one of these is 3-6. So this Renmon can't have 1 on it, because 1 and 2 are in the same column in this box. So this can't be 2, because this can't be 1. So doesn't this Renmon have to be 2, 3, 4 specifically? Yeah. Two, 3, 4, 1, 5, 6. Wait. 4, 5. Oh yeah, 3, 6 go together. Okay, yeah. Okay, so these are from 2, 3, 4. That is a really cool. Wow. Now, if this is 1, this is 2, 3. So, if this is 2, this is 3. What about if this is 3? Oh, but then I can never put a 2 or 4 on it. So this can't be 3, because if it is, I can never put a 2 or 4 on it. If this is 2, this is 1, this is 3. If this is 4, this is 5, and this is 3 or 6. So this is always 3 or 6. And it's specifically this digit, so this is always a 1-5 pair. Wow. I have no idea if that was intentional, but if it was, that is amazing. Let's see. If this is 1, this is 2, 3. If this is 5, this is 3, 4, or 4, 6. Okay. So, what? This is 6, this is 4. What is that? So here is... oh. This is 2, this is 1, 3. If this is 3, this is either 5, 4, or 1, 2. And if this is 4... oh! Hey, Raffles, how was your stream? And if this is 4, this has to be 5. So this is either 3 or 6. Okay. Huh. Ooh. Can this... if this is 6, this is a 1-5 pair. I've been there. I'm just doing another column of the sudoku pillar, then I'm gonna see who's on to raid. Seek. Okay, here is a thing. Okay. Where is... oh, this can't be 3, 6 because they would both see the 3 and 6 in this row, in this box. Oh, it's Avatar Snorlax. Okay, so this is 1, 2, or 4, and there is a 2 on there. So that's not 2, that's not 1. I probably should have... oh, it is possible for this to be a 2. One of these is a 2. If it's 2... oh, and either way, this can't be a 2. So if this is 3, this is 2, this is 1. If this is 3, this is 2 or 4. If this is 4, this is 5, and this is 3 or 6. Wait, but that doesn't work. because then this would be a 3-6 pair and this would be a 3. So this can't be 4. Oh, welcome in, Michael M238. Okay. So now this... Right, and this can't have a 2 on it. So it can't have a 1. Okay, so it's 3, 4, 5, 6. That's not 3. So this is 3, 4, 5. Or 1, 2, 3. This is 2, 4, 6, so it's even. Where are the... well, okay, any of those could be odd. There's also the fact that one of these is 2. Now, if it's here, that's 1. That's 3, 6. 4, 5, 2, 1. 4, 5. Yeah, that works. 2, 1, 4, 5, 6, 2, 1, yeah. Wait. Is it possible neither of these is... Like, is it possible this is 2? 4, 5, 2... 4, 2, 1. Yeah, that works. Ah, yes, trying to remember how Lickitung is spelled. Been there. Though the perfect Poke Rap helped with that. Let's see. Oh, also, because we got vertical roping. Oh, right, because we got vertical roping. If there's a 2 there, that means there's a 1 up here. Right, so this is, in fact, a 2-4 pair. So, in fact, this is a 5-6 pair. Okay, so that's 3 in this column. Ah. Okay. That was cool. That was one of my favorites so far. God, the way the roping works in this puzzle is just... God, that was cool. Meme Rister's Disappointment by Donatello86. Oh, that's starting off strong. Okay. Oh, also Donatello86 has requested a ping. Doesn't seem to be in meme server. Okay, I guess they're under another name. Okay, so it's Killer Cages and German Whispers. Okay. Simple enough. So the minimum of this is 3, 4. Oh, and it can't be 3, 4. Because it would need another 3. So it's 3, 5, 2. Or 3, 6, 1 or 4, 5, 1. So this is 1 or 2. All right. Now, what about here? 9. Oh, hey, Sniglet. The first few slide and see. It took me a bit. It took me a bit to get through. It took me a bit to get the hang of it. But once I did, the first two were, yeah, the first two were really good. Definitely looking forward to trying a couple more of them on Thursday. Let's see. Oh yeah. Right. Good spot, GDC. The box 5 Whisper can't be 3, 6, so there is a 3 in the cage. So it's 3 with the others adding to 7, so it's 2, 5 or 1, 6. So there's a 4 up here. Now, if that's 4, that's 1. I think that's okay. Especially if this is 1. Now, if this is high, it's 6. This being 1 or 2. If this is high, it's 4 or 5, with this being 1 or 2. So the other of 1 or 2 is here. So this is 4 or 5. There's a 4 here. Now, if this is 4, this is 1, making this 5. This is a 1, 3, 6. This would be 4, 5. I think that works. What if this is 4, though? I guess 6 in this box can only go here. Oh. Haven't looked at this. This is... This is 1, 6, 2, 5, or 3, 4. Oh. I can do polarity coloring. This has 2 of different polarities. So don't know if that helps. So these have different polarities. What is that? If this is 3, 4, this is 3, this is 4, this would be 1, 6. Now, because these add to 10, these add to 11. So if this is a 5, this is 4, 2. Wait, no, this can't be a 5. Because these would need to add to 6, and this would have to be 4, but that would make that a 2, not a 1. So this is 4. Okay. So these add to 7. It's either 1, 6, which would make that the 1 and that the 6, or 2, 5, which would make that 2 and that 5. So 1 in this box is here. Oh, so this can't be 1, 6, but it also can't be 2, 5, or these would both be 1. So this is, in fact, 3, 4. Ah, maybe I was incorrect that this has to be... Huh. So I think I said earlier that if this is 3, 4, this is always 1, 3, 6, but I don't think that holds true. Alright, I guess 2 in this column goes here. Oh, this and this are the same. So here is, oh, not quite, no. Ah. Oh, this can't be 2, 3, 4. So there is a 1 in it. 135 or 126. If it's 135, this is 4, which makes this a 2-6 pair. That works. What if this is 126? Oh, but that just leaves 3, 4, and 5, which you can't put 3 and 5. Okay, so it is 135. Oh, that's neat. So this is 2-6. Okay, and now these are opposites. So these are... Okay, so these are 1-5. Ooh, new body video. Oh, this 5 rules 5 out of here. This 3 rules 3 out of here. I keep forgetting to scan using these because I keep mistakenly thinking they're just part of the previous grid. Okay. So, red 2-6. Goes here. Those. Okay. Wait. Oh! This is 4, 5, 6. So I know, in fact, that this is high. Wait. I don't want to select all the reds in a previous puzzle. Okay. So that is 4. And that's 6. I don't even need the coloring anymore. It's 1 or 2. Okay, this is 2 or 5. 1 or 3. Oh. 4 in this box just by sudoku, which forces that to be a 1. Four, 6, 3, and 2. Nice. Productive by Oddly Even. Has oddly even requested a ping? No. Oh, Orabi has. Let me get back to... Alright. Oh, Meme Rister sent Donatello 86 a DM. Okay. Product sum lines. Digits along a line sum to the product of the digits and the squares at either end of the line. Okay. So whatever I get by multiplying these two digits, that's the sum of these four digits. And whatever the product of these two digits is, that's the sum of these four digits. Okay. So I know there's a 1 and 2 on here. So these can't be too high because the max these can possibly be is 14. Well, there's no way to make 14. Because I would need a 7. If it has a prime factor of 7, I can't make it as a product in a 6 as a product line in a 6x6. Because there's no way to multiply two digits together to get 7, because 7 is prime. That's what prime means. And every composite number has a unique prime factorization. So, this has to be... Well, 13 is prime, so there's no way that works. I'm guessing this is 12? I guess it could be 10 if this is 2, this is 5. Well, the minimum it can be is 10. Oh, so it's either 10 or 12. Now, if it's 12, this has to be 3, 4. And if it's 10, this has to be 2, 5. These also all see each other, so these are a minimum of 10. Let's see. If this is 12, could it be 1, 2, 3, 6? No, it couldn't be 1, 2, 3, 6 because this would be 3, 6, so the 3, 6 would have to... Okay, this is either 1, 2... So there's always a 4 on here, and it goes there. And this is either 1, 2, 3, should make this 5, this 2, or 1, 2, 6. Oh, no, wait. No. No. Wait. Or 1, 2, 5, sorry. So it's either 1, 2, 3 or 1, 2, 5. Okay, and now that I can't use a 4 down here, what does that do for me? So So this is at least 11. And I guess the most it can be is 16. But wait, there's no way to make it 16. Wait, doesn't this have to be 12 now? Because 11 and 13 are prime, and 15, this can't be 3 or 5, which is the only way to make 15. Doesn't this have to be 12? Oh, but this is either 3 or 6. And this is 1, 2, 3, 6. Oh. Oh, but only one of these has to go here. But this can't be 1 or 2, so this is 1 or 2. Oh, but wait. 1, 2, 3, 6. That rules 3 out of here. This is 5. Okay, so this is also 12. Okay, so this is 3, 4, 3. Dang, that's cool. This is one of my favorite columns so far. Okay, so there's a 3 there. Okay. Oh, 3 in this box. Which makes... No. Yeah, which... okay. Okay. 1, 2, 5. If this is 5... Oh, I suppose it's technically possible for this to be 1 if this is 1, 4. Yeah, that works. Yeah, it works fine. Alright. If this is 1, that's also pretty forcing. But if this is 2, that's... Alright. I am correct so far, right? Yes, okay, good. But what if this is 5? Six, I guess. That works. Okay, what if this is 2? If this is... I don't think this can be 2. Because if this is 5, these can't sum to 8... or 6 with this being a 3. And the next is 10, which would require another 5. Or 12, which would require... So, okay, so this is number 2. So one of these is 3. What is... Well, okay, this is 1, 2, 4, 6. Now, if this is 5, this has to be 1, right? With this being 1, 4, 2, 6 pair here. Yeah, that works fine. 2, 5, 6. So if this is 5, that's 4. I guess this could be 2, 6. Well, what if this is 4? Oh, this can't be 2. Oh, I don't think this can be 4. Right, this can't be 4. Because this would either be 2, in which case this couldn't be 3, 5, so it would have to be 2, 6, but then I repeat a 2. Or this is 1, in which case I repeat a 1 in the row. So, yeah, this is 4. Okay, and this is... Now, if this is 6, this is 6, 2, 6, 1. Oh, wait. Oh, okay. Oh no, this is 5, 5, 2, 6. That'd be 3. Wait, what happened? I don't... Oh. I think it breaks if this is 3, right? Because it can't be 6 without repeating a 2. It can't be lower than 6. And it can't be higher than 6. Because the next highest is 15. Okay, yeah. Okay, this is not... Okay, so now we got a 1-5 pair. Okay, so this is either 6 with a 1-6 or 10, 2, 5. So this is never... either. Okay, so this is 3. There's a 3 up here. Another up here. Okay. This is 5. This is 1, 4. If this is 5, this is 1. Okay, so there's always a 1 in here. Is this always a 1-5 pair? Wait. What if this is 2? Oh yeah, that breaks any combo of these. Well, it doesn't break any combo of these, but it does rule a 5 out of this domino. Okay, okay. Should have spotted that a bit. So, okay, so this is 2, this is 1. 4, whereas if this is 1, six, 1. Oh, I think 1. Okay. Okay, and that gets that's a 3-5 pair, that's 6. That's 2, which resolves this. 3, 4. Aha! Cool. Nice. Okay, Oripy. German snake. Shades some cells to form a non-intersecting path which does not touch itself orthogonally or diagonally. Black circles indicate the start and end of the path. White circles indicate the cell is part of the path. So it starts and ends on here and passes through these. The snake forms a German whisper line. Oh, and it can't touch itself orthogonally or diagonally. Alright. Let's see. I guess I can do checkerboard coloring. If I knew... These have to be either a 1-2 pair or a 4-5 pair. Because once I know the... if I know a cell is on the path, I can do checkerboard polarity coloring. Okay, and these also have to have the same polarity. And since the path doesn't touch itself diagonally, it must... either go like that or like that. So where does it go from? I know this isn't on the path, because to get here it would have to touch diagonally before it. It would have to touch one of the two ends diagonally and not immediately join it, which is a no-no. Or else it's so short it doesn't take these. I know these aren't on the path, I think. because even if it goes like this, like it could go like that or like that, but it doesn't. Oh, I know this isn't on the path. And I know this isn't because it would have to go through there. Notice the rules don't actually say that the path only moves orthogonally, but I guess if you're supposed to shade the cells to make the path, that would... Oh, but now this can't be part of it because that would make a 2x2. So the path, so the loop, the path never enters this row. Oh, and I think this always has to, however it enters here, it can't, yeah, it has to go through here. So in fact, okay. That's low and these are high. So that's 4, that's 1. This is a 4-5 pair. This is a 1-2 pair. And wherever this goes next, it has to be another 1, which can't... Okay, it has to go like that. Now, since the path can't touch itself, must go there. Aha. Okay, so that's... This is any of 1 or 2. So we got a 1-2 pair here. This is 3 or 6. This is the other of 3 or 6 with this digit. All right. Oh, this 1 looks across. So this is 5. So this cannot go here. Oh, this rules 5 out of here. Oh wait, this can't be 4 because it would have to go to another 1 right away, so it's 6. Okay. So there's a 6 down here. Three or 4 to finish the row. I know it doesn't come here, because it would be 3, but then it would need to go to another 6. So it goes down here. 2, 3, okay. That's a 2, 3 pair. Having 1, 4, 5 to finish the aha! Question is, does that mean it comes down here? If it doesn't, I guess that's allowed. But that does leave here. So now it has to come down here because if it doesn't take this cell, it goes through here and now it has to take 4 1s. Okay, so that's 2. Oh, also that had to be 2 because otherwise it would need to take a 6 that would see this 6. Oops. Okay, and if it goes here, it can never get out. It doesn't go through here because those are consecutive. Okay, that's 2. I mean... Oh! Well, it doesn't go down because these would have to both be 6s. So it just goes... So it just goes across there. Okay. Path is done. Wait, how am I going to resolve these? Oh, maybe it's something... Oh, yeah, this 2. Okay, that's 2. Right, that's 3. Okay, that looks up. That's 5. That's 1, 6, which looks up and resolves this. Okay. Okay, and I'll just... Okay, Parody Party by Lularo. I don't think Lularo requested a ping. Nope, right. Okay. Okay, so it's even, odd, and Kropgita. Oh, okay. So there's no Parody Party clues. Okay, so it's just telling me the parody of various... Okay. Okay. I see what you're... Like... Okay, this can't have a 2 or a 6. So it's 3, 4, 5, and there is a 4 on here. Alright. This is 2 or 6. This is 1 or 3. Oh, where does 1 go in this box? Alright, this is 1, 3, or 5. Okay, so that's 2 from 1, 3, 5. So the remaining odd must be here. Okay, so this is 2, 6. These are even. Okay, so this is 3. Yes, parity is important. Okay, that's 2 or 4. So this is 2, 4, 6. This is 2, 4, 6. Aha! So these are... That's all the evens in this column, so all of these are odd. That's 1. Oh, and these 2 evens and the even here. Okay. I should have spotted that sooner. Okay, this is either 3, 2 or 5, 6. Virtual 3, 5 pair. Okay. 4 up here. Oh, this is also all the evens. Oh, where does 1 go in this box? It goes up here. Okay, okay. Oh, that's 5. Got it. Oh. Oh, the 2 resolves this, which resolves this. All right. Nice. All right. Oh, that was fun. Thank you all for joining me. Looking forward to more of this, more puzzles on Thursday. And more Can of Wormholes on Saturday. Alright, who's on to... Well, Chatty Cathy featured one of my puzzles on Saturday, so... Oh yes, I should close out of that. I'll raid Chatty Cathy. On Twitch, anyway. So, go say hi to her, and I will be back on Thursday. Yeah. Thanks, and bye.